You have most likely heard of dynamite, whether it be Napoleon dynamite or related to explosives, but we are here to educate you about the latter. The name dynamite actually stems from the Greek word dynamis, meaning power. Dynamite is a combination of multiple ingredients, but the most important ingredient, and the reason for its explosive nature, is nitroglycerin. Nitroglycerin was first created by the Italian chemist Ascanio Sobrero in 1847. Nitroglycerin is highly unstable and is very delicate to make. Before dynamite, it was commonly attempted to be used in construction and mining projects. Once created, it can easily detonate and cause unwanted explosions. This makes nitroglycerin impractical for most applications, due to the fact that it would most likely explode during transportation of the material. This led to a desire for nitroglycerin to become practical. Enter the genius, distinguished, well-bearded inventor named Alfred Nobel!
Alfred Nobel is on a personal crusade to make nitroglycerin safer. The deadly explosive has already killed his brother. Now, according to legend, another near disaster sets him on the path to his greatest discovery. A beaker of nitroglycerin is knocked to the floor. An absorbent clay-like substance found along the riverbanks of the Elbe. Called kieselguhr, it contains the fossilized remains of a hard-shelled algae. When mixed 75% nitroglycerin to 25% kieselguhr, the silica in the kieselguhr absorbs the nitroglycerin, preventing the decomposition that made it so unstable.
Alfred Nobel, a Swedish chemist and engineer, as well as the founder of the Nobel Prize, patented the explosive in 1867. His goal was to provide a safer yet stronger alternative to gunpowder. Nobel invented the detonator, which made it possible to ensure a controlled explosion of dynamite. At the time, dynamite was mostly used for blasting rock away in construction, but today, dynamite is also used in demolition, mining, and quarrying. For example, before dynamite was patented, nitroglycerin and early forms of dynamite were used to help blast the way through the Sierra Nevada mountains to help complete the Central Pacific Railroad, which led to the first transcontinental railroad in North America. Dynamite is also the explosive of choice in many films and cartoons, such as The Bridge on the River Kwai.
Dynamite itself has many practical uses beyond blowing stuff up for the fun of it. We have been able to use its destructive power in a relatively safe manner. In fact, it single-handedly revolutionized the mining industry by making the excavating of drilling holes safer and more effective. The mixture contained in dynamite can also easily be turned into a paste, which can be shaped into rods and be inserted into drilling holes for mining and excavating. The introduction of dynamite also reduced the cost of construction projects, such as rock blasting, building canals, and demolition of old buildings. A semi-local example is the demolition of the RCA Dome in Indianapolis in 2008. Beyond the industrial uses, dynamite has military uses. The onset of World Wars I and II saw the use of dynamite to fuel war machines and weapons. Nobel did not want to be remembered for being the man who created the explosives responsible for so much death and destruction, so he used his fortune to start the Nobel Prize series, securing a more positive legacy. To create nitroglycerin, all you need is glycerin and nitric and sulfuric acids. Add 13 milliliters of nitric acid to a 75 milliliter beaker in an ice bath, and add 39 milliliters sulfuric acid, mixing slowly. Cool the mixture to around 10 degrees Celsius. Slowly add glycerin, which will float on top of the acid. You want to cover the entire surface. Again, add the glycerin slowly. If the temperature exceeds 30 degrees Celsius, dump the mixture in an ice bath and run. Assuming you are careful and don't blow your lab to tiny pieces, the nitroglycerin will form on the top layer of the solution after about 10 minutes of gentle stirring. Transfer the nitroglycerin into sodium bicarbonate, which will neutralize the remaining acid and make it a bit more stable, though it is still dangerous. Remove the nitroglycerin from the sodium bicarbonate with an eyedropper. The easiest way to test for the purity of the product is to place a single drop on metal and ignite it. True nitroglycerin burns with a clear blue flame.
For the mechanism, nitroglycerin can be created by the acid-catalyzed nitration of glycerol. The mechanism for the synthesis of nitroglycerin is fairly simple. Sulfuric acid mixed with nitric acid results in the formation of a nitronium ion and water through proton transfer. When exposed to glycerin, the nitronium ion adds to one of the 3 available hydroxy groups, forming the intermediate shown. The oxygen connected to the nitrogen is then deprotonated by the sulfate ion from the sulfuric acid catalyst, and sulfuric acid is reformed. This mechanism is carried out 3 times, once on each of the hydroxy groups, giving the final nitroglycerin product. We previously mentioned to add the glycerin slowly and in an ice bath. This is because the addition of glycerol is exothermic. If the reaction gets too hot, it results in a runaway reaction, where the product rapidly oxidizes, the nitration process accelerates, and nitrogen dioxide gets released, which is very dangerous. For this reason, the glycerol is added to the acid, not acid added to glycerol. This is to better control the reaction and prevent explosions. In the industrial process of generating nitroglycerin, there must be extra safety precautions taken to ensure that there will not be any unwanted explosions. For example, most reaction vessels contain a trapdoor at the bottom which is suspended over a tank of very cold water. If the temperature exceeds 30 degrees Celsius, the reaction is then immediately drowned, meaning it is dumped into the cold water to prevent a disaster.
So now you have nitroglycerin. In case you didn't notice from our warnings, it's a bit dangerous. Even impure nitroglycerin is extremely explosive. Nitroglycerin is a colorless liquid that is extremely unstable. It is a contact explosive, meaning physical shock can cause it to explode, making it highly dangerous to transport or use. Even just bumping nitroglycerin can be enough to cause a potentially deadly explosion, which is scary, but allows you to do things like this. Nitroglycerin undergoes a decomposition reaction in which much more stable gases are formed, such as nitrogen gas, carbon monoxide, water vapor, and oxygen gas, which makes the quick reaction violently explosive. The reaction itself is triggered by an initial decompression of nitroglycerin. The shock from this initial decomposition creates a supersonic pressure wave, causing a pressure-induced decomposition of the surrounding fuel and an explosive blast. A blast of 1 200-gram stick of dynamite can contain 1 megajoule of energy. Most of this energy comes from the rapid expansion of the gases formed from this decomposition reaction, as 4 moles of liquid nitroglycerin produce 35 moles of gas. Undiluted nitroglycerin is one of the world's most powerful explosives and is comparative to RDX and PETN. Dynamite is rated by the amount of nitroglycerin it contains and usually contains 20 to 60% by weight. The rest is composed of diatomaceous earth, also known as diatomite, and as the absorbent, and a small amount of sodium carbonate as a stabilizer to neutralize trace quantities of acid. Ethylene glycol dinitrate is sometimes added to lower the freezing point to keep it from freezing at a moderate temperature during transport or storage. Clearly, dynamite is epically explosive and can blow things to smithereens like nobody's business. However, its stable nature allows it to be used for a wide variety of things, from explosions in movies, to mining, to demolition, to plain old having fun blowing things up. When it's all said and done, dynamite is the bomb.